Hello, I'm Chris and I am a KMP developer. And today we're going to be reacting to a code opinion video about starting with a monolith. And tech support's coming out Tuesday for that. Close that thing up finally. Get out of my hair. All right, let's go. Let's get this going.
If I were to start a greenfield project today with a small team, I'd create a monolith, not microservices. Here are the reasons why I wouldn't start with a microservices architecture and why boundaries are key. Hey everybody, it's Derek Martin from CodeOpinion.com. If you're new to my channel, I post videos on software architecture and design in .NET, so if you're into those topics, make sure to subscribe. So when I'm talking about a greenfield project with a small team, really what I'm referencing is the idea that I'm going into a domain that I do not know anything about. I don't have any existing system as a reference point. My knowledge is I'm a blank canvas. I don't really know anything yet. And I've said this over and over again, is that getting boundaries right within a system are really difficult to do, in my opinion, yet they're the most important thing to do. And when you're creating a new system, being able to refactor and change the way that the system works or your understanding of how the system works is going to be much more feasible in a monolith than they are microservices.
Yeah, so as a KMP developer who's going to do a MicroMonopoly, it's actually important to keep it to a monolith, at least in the beginning. Your MVP definitely should be a monolith. You're not trying to do anything fancy. You can always scale it up later. If you do what he's talking about in this video, if you keep these bounded contexts, meaning each service that's inside your monolith can only access its own data, and that's a strict boundary. It only goes through the service. Can't access the data. No other service can access the database directly. That's when you get in trouble, and it makes it very difficult to separate things out. But if each service has its own database or its own table, which he's going to get into, then it makes it easy to scale up these pieces, whichever one you find out is going to be the one that's going to be the bottleneck. Which, if you're having less than 100,000 customers, it's probably not going to be an issue. Just use Redis, right?
So
that's what my answer is going to be. Redis.
The analogy I always use when I'm talking about kind of discovery and boundaries is I like to think of the system as, say you're walking into a pitch black room. So you open the door, it's completely black, and all you really have is a flashlight. What you're doing is you're kind of shining that flashlight around. You're kind of getting the feel for what the room looks like, the things in the room, kind of where everything is potentially in that room. As you're shining the flashlight around, over time, you become more familiar with what is in the room. You get a better kind of conceptual idea of what everything is, where stuff lies in the room. That's kind of
that's just knowing your business domain, and trying to think about how your business process that you're going to be using in your MicroMonopoly, how your business is going to run. And what things need to be accessed and when and how and all that stuff. That's what you're going to need to know. So it's kind of difficult to know that ahead of time. And that's why keeping it small and simple is key in the beginning.
Kind of like, to me, walking into a brand new domain that you have no idea about. You're going in blank. You can't see anything. You don't know anything. And it takes a lot of work and discovery to figure out where the boundaries lie. And most importantly, when we're talking about boundaries, is what are the capabilities within a boundary?
He's talking about like commercial software developers who have to go, who are they're tasked with getting some other business that does know their domain, going in and trying to explore that domain as a software developer to try and fix their issues. Because the people in the business, they know their domain. They know all the little special weird quirky rules and strange things that work in a bizarre way that is normal to them, right? And that is what micromonopolies need that information. That's the information we need, is that some market somewhere, some niche, something that's being underserved by someone that's kind of already in that business space, whether it's you as the sole developer who's seeing these things, or you find a business partner who, the low-hanging fruit just got, the low-hanging fruit got lowered, and it's only the micromonopolies that want to take advantage of this that are going to be, that can see these opportunities.
What are the business capabilities? And behind that, what's the data behind those capabilities? So figuring out boundaries is probably the most difficult thing to do. And if you're going to try to start off with microservices, what services are you creating? You don't really even know yet. So in the videos and talks I've done about a loosely coupled monolith is a monolith isn't a big ball of mud. Really what I've done in a lot of the videos that
So the big ball of mud, I think what he's actually referring to there is when each one of these services is tightly coupled to another one, or accessing a database tables directly all over the place. And that's when it gets to be, oh man, I've seen so many projects grind to a halt. They just were abandoned. I mean, I might be okay to do that stuff, that direct database access and all that kind of stuff in the beginning, like right in the very, very, very beginning. But as soon as you want to get like, okay, we kind of know what this is going to do. We don't know exactly what's going to do, but we do know these are the bounded contexts, and we're going to make sure these things are bounded properly. Yeah, that's a bit of a challenge at first, but if you know your business and you're the technical person working with a business person, or you see this opportunity, I think we have enough information now that we could probably figure it out. But like, going through Derek's videos will get you thinking along these paths and understanding how to build these things in the back end. And he's got a little bit of jargon. He uses a little bit of jargon, technical jargon, but it's not too bad. I'll be your translator. Okay.
That created is I'm really talking about building a monolith, kind of using the same ideas that you would essentially use within microservices, but using them within a monolith. That's why.
Now, what he means by monolith is it's deployed as one big program. That's all it is. It's one jar file. That's a monolith. So everything, all your services, all your different sub-functions are all inside that one program. And has different entry points, right, for each one of the functions that your services. Everything's right there, all in one place. And KTOR, that's kind of the natural out of the box how it works. And you can get a lot done with just that. So it's not like you're limiting things. It's like kind of a positive feature, honestly, because small teams, which is what we're talking about, can get a lot done, man.
I call it a loosely coupled monolith, is that you want to reduce coupling. Even though you're deploying a single monolithic application, that doesn't necessarily mean, I think, what it does to most people or perceive to what a monolith is. I think most people think of a monolith as this. They think of just this monolithic application that is a big ball of mud that there's a ton of coupling to, and you have a single database.
And we talk about the coupling is like the direct access. Services directly accessing each other without some kind of standardized messaging queue system or some kind of other things like that. If everything's directly accessing each other, if you can get this situation where you get locked up, right? So you can have service A, we need service B, and service B needs service C, and service C needs service A, and and that's why the event-driven stuff makes a lot of sense, because it's much more difficult to get in those situations if everything's event-driven.
But that's not really the case. Is really what I like to think of is first is having well-defined boundaries within that monolith so that you don't have type coupling between these things. So in the example of my loosely coupled monolith, I kind of have three different contexts. I have a sales context, a warehouse, and billing. And there could be more than this. And generally what I've been showing.
And what he means by this is like, this is a separate service. Sales only accesses the database for tables for sales. Warehouse does not access the sales schema directly. If warehouse needs to know something about the sales schema, it's going to go through the sales API. There might be public API. There might be private API, right? But we're not going to go through and directly access these schemas and these different tables and different actual columns inside the tables. You're not allowed to access those directly, because you might want to upgrade those and change them around. And if this thing's accessing and this thing's accessing, that means that every time you want to change it, you have to go and change the one in warehouse, change the one in building. But if everything goes to the API, you can update this stuff and update it just in one place, right? That's the big idea. That's the big idea.
Showing in some of my slides is that each one of those contexts has its own database. Somebody posted a comment in one of those videos saying, can I just use the same database and make sure that the schemas are kept separate? Exactly. This is a conceptual idea, not necessarily a physical one. So it doesn't need to be that your monolith has a single or has a database for each different boundary within it. It could be a single database instance, but there's its own schema within it. So for example, sales
means a different table. A different table is going to have different schemas. So the order is going to have like, your order ID and what you ordered, and the warehouse is going to be how much stuff each item is in stock, and the billing is going to have the address for the customers. That's all the schema is. These technical terms are silly.
Within our loosely coupled monolith here is referencing this database instance and just referencing its particular tables or its schema that it has. The same thing.
So this is one database, and the database is going to have multiple tables, and then each table can have multiple columns and rows. That's how it is. It's like a spreadsheet. Ooh, it's a big spreadsheet. Ooh. So you can think of them having these different tables, different for your spreadsheet, different sheets in your spreadsheet. And as long as the sales software, your service here for doing the sales operations is the only one accessing it, then you can get away from it. But I have worked on projects where that was not the case, and oh my God, it basically just ground a halt. I'm repeating myself. It was just so traumatic dealing with that stuff and looking at this thing, how it worked, and you had to like go through somebody else's. You had to know exactly how everything worked and where everything is and how it's all. It was a mess.
thing with warehouse and the same thing with billing. There's no billing referencing or making calls and queries to this particular schema or the sales schema. They have their own schemas, and we don't want to couple between using our database. So yes, you're using a shared database server, but you're not coupling by schema. These things are still independent. So
right, he's just saying that billing is going to only access the billing. So if the warehouse tries to access billing, we're not going to go let that happen. Only if warehouse needs to do something, warehouse is going to access the service, not the actual database tables. Because people used to think you could do that. No, you can't do that.
Another way to show this is this.
Well, you can, right? For limited, smaller applications, right? You could get away with this stuff if you had all kinds of rules, but it makes it very difficult when you want to scale these things. Billing needs, if sales is getting 100, if you need to scale this thing out, you need to have multiple copies of this surface running because you have so much traffic coming in. Well, then, yeah, it makes it easier to split this stuff out and scale it up. You're not interrelated with everything else. But as soon as that happens, you're going to start wanting to have an event system because it just gets hairy. This is still very directly coupled, but at some point, there's going to have to be an event bus.
Conceptual idea is you could still view it like this, where each different boundary within your monolith has its own database.
Fine, too. The same thing is this is the same thing. So it's not going to have any other tables other than the tables it was already using before. So it just keeps them physically separate. Okay.
And if you were to do this, okay, you have a single instance. If you were to do this, you could actually do this. You could actually have each different context have its own database. And as I've mentioned, if that's the case, then you can, in my scaling video, you can decide to scale these databases differently, or maybe add read replicas to sales, whatever the case may be. Maybe this needs to be a larger instance if you're in the cloud, whatever the case may be, is that you can scale these differently. But conceptually, it's just that each one has its own database. But yes, you could use a shared database. So the next piece of the puzzle that I've always mentioned,
and probably for MicroMonopoly, you probably want to have a shared database. So just make it simple. Once it starts going crazy, then you can scale it up and don't have to worry about it. But in the beginning, you want to do these experiments. You want to run all these experiments. You don't want to spend a lot of time and energy building these things if you don't have any customers that are not going to be there. So there's so many projects where there's more resources and databases than there are customers.
Is to use a message broker. And that's where the asynchronous messaging, the loosely coupled part of it comes from, is that instead of these particular boundaries communicating in process with each other, you're still publishing messages and events to a message broker and consuming them basically within your monolith. So everything's coming out from the monolith and back into the monolith, but reaching the particular boundary that actually cares about those particular messages. Yes. So if you go from here, you can think of, well, if billing has no dependency on any other particular boundary and it has its own database, then really what you're doing is it's just a deployment concern at this point. You're just deploying this monolith together. And if you want to get to the point where you need to scale differently in terms of actual team size and scaling becomes not necessarily a request load issue, but actual development people working on an actual particular part of the system, and you want to deploy those things separately, then you can start separating these things into microservices or services, whatever size you consider these things, and just be them independent. And guess what?
Or just, even if it's not separate teams, just your thought process, how you think about this thing. Having it set up, you separate it out, like whatever your domain is, having it set up like this, separate it out, it just makes your life so much easier by maintaining it, explaining it, and maybe having somebody else work on it instead of you. It makes it just so much simpler.
What you're using microservices architecture. In my opinion, creating a monolith using the same concept and principles as you would as microservices at the beginning of a greenfield project with a small team is easily the way to go. If you need to refactor, which you will, as you make more discoveries, as you're shining that light.
If you're lucky. You
can move code around into different boundaries, if you got to move something from sales or a piece of data from sales to billing or warehouse, wherever the case may be, you can refactor this because you have a single unified code base and you're deploying that code base as a single unit.
Yeah.
So if you, for example, need to change a particular message or you need to change the properties of the data in a message, you can refactor that. And you know with certainty that everywhere else a part of the system is going to be using that new event or that new property. You don't have to worry about, is there this old service? We need to version this and keep backwards compatibility. Everything's getting changed at once. If you need to move things around, you're doing it in a single unified code base. And as I said, boundaries are hard to get right.
Yes.
In a monolith, it's going to be way easier to move stuff around and refactor than it would be in microservices. If you enjoyed this video, please give it a thumbs up.
Yeah, and go give him a thumbs up and give him a subscribe and all that stuff. He's the best as explaining some of this back. And he does use a little bit of this technical jargon terminology, but once you get through that and understand what he's talking about, it's like, oh, you're saying make it simple. Oh, you make it seem like we have to do this little complicated thing. No, we're talking about we're simplifying it, trying to simplify this thing. That's what we're trying to do. We're not trying to be fancy. We're not trying to do crazy old Kafka map reduce. No, we don't need to do that stuff. Unless that's your use case, I guess. But that's not really what I'm talking about with these micromonopolies. I mean, no. So give me a like and subscribe, and we'll keep going.